Welcome back. We are continuing acid-base chemistry. This video will cover hydrolysis of salts. So when we dissolve salt in water, right, it'll ionize into their ions. So if we think about table salt, sodium chloride, it's going to ionize into sodium and chlorine. And it turns out that these salts can produce acidic or basic solutions when they are dissolved in water. So when this happens, this type of reaction is called a hydrolysis reaction, So we can form different types of salt solutions, right? Ones that are either neutral salts, meaning they're at a pH of 7, acidic, they are at a pH of less than 7, basic salts higher than a pH of 7, or we also have some salts that can form acidic and basic ions in solution, where we'll have to look a little deeper to see what the pH of the solution will actually be. So let's talk about neutral salts, which form from a strong acid or a strong base, such as hydrochloric acid or sodium hydroxide. So the salts that hydrochloric acid or sodium hydroxide can come from include sodium chloride, the example I talked about, table salt, right? So strong acids and strong bases, they don't undergo hydrolysis, right? They remain at a neutral pH of 7. And I lost my train of thought. Okay. So going back to the point where I said they come from a strong acid or a strong base. So you think about sodium hydroxide, right? Sodium is a conjugate acid of the strong base, sodium hydroxide, and then chloride ions, is the conjugate base of the strong acid, hydrochloric acid. But if we dissolve sodium chloride in water, right, it doesn't hydrolyze to form an acidic or basic solution. Turns out the solution will be neutral. So because of this, right, the sodium ions and the chloride ions are what we call spectator ions. They're just sort of like, they're hanging out in the solution, they're watching, but they aren't contributing to the acidity or basicity of the solution. So we call them spectators. They don't affect the pH of a solution. Acidic salts, these are formed from a strong acid in combination with a weak base, like ammonia. So the cation or the acid does undergo hydrolysis, and we do end up forming hydronium ions, which is what makes the solution acidic. So here's an example. If we have ammonium chloride, we dissolve this in water, right? It's going to ionize to ammonium cations and chloride ions. Now, the chloride ions are spectators, right? So they're just going to be in solution. They are not going to hydrolyze. However, the ammonium ions will hydrolyze with water. So we get this hydrolysis reaction, which is ammonium reacting with water to form hydronium ions, and then we form the conjugate base of this weak acid ammonia. So we form ammonia, which is the weak base of ammonium. So because these hydronium ions are released as a result of the ammonium ions hydrolyzing with water, we end up with an acidic solution. Basic salts are formed from a weak acid like acetic acid, and we're going to talk about acetic acid is our go-to for weak acid, and a strong base such as sodium hydroxide. So the anion, which in this case will be acetate, does hydrolyze, and we release hydroxide ions, making the solution basic. So let's look at an example. If we have sodium acetate, this solid, and we dissolve it in water, we're going to ionize it into sodium ions as well as acetate ions. Now the sodium, remember, is a spectator ion, so it's not going to hydrolyze, but the acetate ion will hydrolyze, right? It will react with water and we will form acetic acid as well as the conjugate base of water, hydroxide. And so because we release these hydroxide ions in solution, this makes the solution basic. Now we have some examples where we have salts that are both, that can release both acidic and basic ions. And I think I wrote this reaction wrong, right? This should be ammonium acetate, ammonium acetate. So ammonium acetate, so pretend that that sodium was ammonium. It would, so if we put that solid into water, we would get ammonium ions, and we would get acetate ions. So ammonium is a weak acid and acetate is a weak base. So in order to determine like what the pH of such a solution would be, it would depend on the strength of the cation and the anion. And the way that we would compare these relative strengths is by looking at their equilibrium constants, their Ka and Kb values. So ammonium, because it's a weak acid, is going to have an associated Ka value, and acetate, because it is a base, will have an associated Kb value. So we would compare the Ka and the Kb to determine what the pH of the solution will be. So in this example, right, so if you were to look this up, you would find the Ka actually for acetic acid, and we can use our relationship with Kw to find Kb. It turns out that the Kb for acetate is 5.6 times 10 to the minus 10, and the Ka for ammonium is the same number. So in this case, our Ka and Kb are equal. So the solution would be neutral. It would be a pH of 7. So you're probably already thinking our rule of thumb is if the Ka of a weak acid and the Kb of the weak base are equal, then we would have a neutral solution. But if our Kb is larger than our Ka, we'll end up with the basic solution. And if our Ka is larger than our Kb, the solution will be acidic. The solution will be acidic. So taken together, if we have an acidic or a basic salt, that means that it will hydrolyze with water. And that just means that it will interact with water either as an acid or a base to release hydronium ions or hydroxide ions, thereby making the solution either acidic or basic. Neutral salts, we only end up with spectators, so they don't hydrolyze with water, so they form a neutral solution, pH 7. And then we also have some salts that will release acidic and basic ions, and for those to determine the pH, we have to compare their equilibrium constants. We have to compare their Ka and Kb to determine if the solution is neutral, acidic, or basic. So this concludes hydrolysis of salts.